In this video, we'll look at how to analyze the data collected from the experiment on the iodine clock reaction. Here you are looking at the effect of changing concentration and changing temperature on the rate of the reaction. The iodine clock reaction is complicated. There's the reaction. Iodate reacts with bisulfite and produces a slurry of products. In the reaction, we were waiting for the bisulfite to get used up. When it got used up, the reaction then produced a blue complex of starch and triiodide. So the last step of this mechanism took place when the bisulfite was fully consumed. So the average rate of our reaction is going to be measured as the change in bisulfite concentration over change in time. Since the bisulfite change is final minus initial, and the final concentration is 0, then the average rate of the reaction is calculated by taking the initial bisulfite concentration and dividing by the time for the blue color to appear. So that little formula we're going to use in our data tables in just a moment. Average rate is the initial bisulfite concentration divided by the time for the blue complex to appear. We're also going to do dilution calculations. C1V1 equals C2V2 is the formula for dilution. C1V1 tells you the moles before you diluted equals C2V2, the moles after you diluted. So the initial bisulfite concentration in each of our test tubes would be C1V1 divided by V2 in doing a dilution calculation. In the experiment that we did, we used a 0.0020 molar solution of sodium bisulfite. So this was the concentration of the bisulfite in the bottle or in the beakers that you took from in the fume hood. So you have a data table like this. You would have done part 1 or part 2, but you would have the data from another group that you worked with. So you should have both part 1 and part 2 tables filled in with data. So you measured the time to react. So for example, most people found that trial 1 in part 1 took about 30 seconds. So I'm going to say 30 seconds was required to react. Maybe it took 28, maybe it took 31, but it took around 30 seconds. Now in this test tube, you took 10 milliliters of the 0.002 molar sodium bisulfite, and you mixed it with 10 milliliters of potassium iodate. So there's your dilution. So in this column here, we want to calculate the concentration of the bisulfite. So as we just saw a moment ago, it would be C1V1 divided by V2, the dilution formula. And so C1 would be your concentration in the bottle, so that's 0.0020. V1 is the volume you used, so 10 milliliters was the volume we used. And V2 is the total volume in the test tube, which was 20 milliliters. So basically you're taking 0.002, multiplying by the volume you used, 10 milliliters, and dividing by the total volume, which was 20 milliliters. You'll do that same thing for each of those boxes in that column, and you'll have the bisulfite concentration in each column, right? Sorry, in each trial. The iodate concentration, the bottle was 0.015 molar potassium iodate. You can see that in the table here. 0.015 molar potassium iodate was what we used. We need to calculate its concentration also, and that's done the same way using a dilution calculation. So notice that the bisulfite concentration, the HSO3, it's going to be the same in every trial because you used the same volume, 10 milliliters in every trial, and you used the same total volume, 20 milliliters in every trial. So the bisulfite's concentration is the same all the way down. But the iodate concentration rather, is dropping. because in trial 1 you used 10 milliliters, trial 2 you only used 9 milliliters, trial 3 you used 8 milliliters, etc. So when you're doing the dilution calculation for iodate, C1 is its concentration from the bottle, so 0.015 molar. V1 is the volume you used in that trial. So for trial 1, you used 10 milliliters, but trial 2, you only used 9 milliliters, etc. V2, again, is the total volume in your test tubes after diluting. So V2 in every trial is 20 milliliters because you also started adding water. So V2 is going to be 20 in all of your trials. So now you will have calculated the concentration of bisulfite using dilution calculations. You would have calculated the concentrations of the iodate also by dilution calculations. The last thing to calculate here is the rate of reaction. And we said on the first page that the rate would be the concentration of bisulfite initial divided by the change in time. So in other words, you're going to take the concentration of bisulfite in that trial, and it's the same in every trial, and divide by the time in seconds, and that'll give you the rate of the reaction. All right? So you're going to have rates going down that column. Now, once you have that, you're going to create a graph. The graph you'll create is going to be a graph showing how changing the iodate's concentration affected the rate. So you'll put rates on the y-axis, you'll put concentration of iodate on the x-axis, molarities. This will be molarity per second. You'll choose appropriate scales, and then you'll create a graph. You'll put a title. The title of your graph could be the effect of changing iodate concentration on the rate of the reaction, or something like that. In part 2 of the experiment, this time we're looking at the effect of changing temperature on the rate of the reaction. So again, you would have measured times to react, so these are measured. You have that in your data table already. The bisulfite concentration is calculated the same way as it was up above, so this is a dilution calculation. C1V1 divided by V2 will give you the bisulfite's concentration. You're using the same volume in every trial here, so it'll be the same number all the way down. You also have temperatures recorded in degrees Celsius, and then the reaction rate is calculated the same way as we did in the table above. This would be the concentration of the bisulfite divided by the time required, okay, and that'll be molarity per second. So now you'll have 1, 2, 3, 4, 5 different temperatures, and you'll have 5 different reaction rates. So now you can make a second graph. This graph would show you temperature on the x-axis in degrees Celsius and the rate in molarity per second on the y-axis, and put an appropriate title. All right, so there you have it. Let's look at the calculations at the end. Show me here a sample calculation for how you got the iodate's concentration in trial 1 of part 1. In other words, show me how you calculated this number here for iodate, right? So basically show me a dilution calculation. In step 2, show the calculation for finding the rate of the reaction in trial 1, part 1. In other words, show me how you found this rate. So show me the calculation of rate in trial 1 of part 1. Step 3 and step 4 describe the construction of those graphs that I just mentioned. You can use graph paper and do them by hand, or if you feel competent using a computer, you could make a graph with Excel or Google Sheets. Just be sure you're making your own graph. You're not taking a graph from somebody else. Now there is something important though on each of the graphs. You can do it on the back of the graph, or you can put a text box or something on the front of the graph. I want you to write a little point form explanation using collision theory that explains the results of your experiment. That basically is coming right out of your notes, right? In our notes, we explained how changing concentration should affect the rate. So use collision theory explanation from your notes to explain what should have happened. And you can also talk about whether that's what you saw. So did your experiment show that that happened? If your experiment didn't show what you expected, you can discuss that there as well. But that can be done in point form. Okay, you don't need to write a big paragraph. On the second graph, same thing. This one's a bit more complicated because we're changing temperature. So use collision theory again in point form to explain how changing temperature should have affected the rate of the reaction. And then did your experiment show that? All right? So you're making two graphs. With each graph, you're going to put a little point form explanation of the effect of concentration and the effect of temperature on rate based on collision theory. And you're going to show some sample calculations for the concentration, a dilution calculation, and for the rate using the formula that we used on the first page. All right, so that's your lab that you can then hand in on Google Classroom.